yeah, I'm Omar Almousa. I'll be talking about my recent work about analyzing password string for Sophomores. So new students coming to university, they are picking their passwords, and I'm just kind of navigating their patterns and picking new passwords. So to outline or the agenda for the talk, I will be talking about some background, what is a password and why they are important, and what is a weak password and how dangerous or risky it will be to have weak passwords into your system. My methodology, I will talk about the data set and data processing parameters and classes for passwords. I will finally, before I conclude, I will show some results, and finally I will conclude with some remarks and future work. So passwords, as you all know, are everywhere, and this will continue for a very long time. They are very cheap, and they are very usable, and they are kind of natural nowadays. I mean, the first thing people think about when picking authentication method, they will go for password. Okay. Of course, now it's being strengthened with this multi-factor authentication, biometrics, and stuff like that. But still, the password, the text password, the usual password is there, and it is predicted that it will be there for long. Strong password are a necessity, so we need them to protect sensitive data information. Unfortunately, people are picking weak passwords, or they are reusing passwords in different systems. So they are using the same password in different systems, which is more than half of people are doing this. So a weak password is very risky on any system, because it not only may jeopardize the system that you are in, it also may lead, because of this password overlapping or password reuse within systems, it may put at risk other systems. Investigating users' behaviors in password creation, it will lead to finding ways to avoid these weak passwords. So what data set we have? We had a platform for students to exercise and submit their programming assignments at the university. And those were fresh students at our faculty, Computer and Information Technology faculty at my university. And then those fresh students, of course, were asked to create their accounts and, of course, picking their passwords for this programming platform that we developed in-house for this course. So we can assume that those were realistic passwords that the students picked them. And we also assumed that the students are taking that seriously to protect their assignments and to protect their tasks. But we found out that this is not the case, as I will be showing at the end. The password list of 671 passwords, we anonymized them, and we cleansed them, so blanks and non-serial accounts that were created and not reached the password creation stage were also eliminated. So and the result, we had 662 passwords. Of course, the whole system, this programming platform, it was deployed for like a year, and after that we just shifted to another platform. So those passwords, we could say those are obsolete, but they still have some meaningful information within about the behavior of users picking passwords. So the remaining data set consisted of 662 passwords. Parameters of the password, basically the very basic, the usual suspects, as they say, the length, of the password, how many characters are there? Does it has small characters? Does it have capitals, special characters or symbols? Of course, there are some integer parameters like how many, and the Boolean parameter if it exists or not. But finally, we have this entropy that our invited speaker talked about. Of this entropy, the measure of information in the data source, and we had it for passwords, where L is the length of the password, while N is the size of the alphabet, the whole alphabet. And of course, the alphabet varies according to which data set is used to generate this password. So if you are only using digits in your password, so your alphabet will be just of size of 10, the 10 digits, while if you are using only small letters, no digits, no symbols, nothing, it will be 26 and so on. So yeah. Yeah. So according to that parameters, we had different classes of passwords. So the passwords that are digits only are, so the size of the alphabet is 10, the 10 digits. A percentage of students who created these passwords were almost the third, so 30% almost. Which is, I mean, yeah, not very good piece of information. One case letters, so only letters with either small letters or capital letters, where the alphabet size is 26. We have 2% only. One case letters in either capital or not both, either capital or small letters with digits. The alphabet is of size 36, so the 26 for letters and plus 10 for digits. Those were 15%. Digits and symbols only, this was very negligible percent, I mean only 0.3%. So yeah, so 10 for digits and 32 for symbols, special characters like a $sign or pound sign or underscore, all those we consider as special characters or symbols. And yeah, as you see, I mean the most wanted one, I mean the last case, the two or last class, 2 case letters plus digits plus symbols. So any one of those had an alphabet size of 94, which is basically 32 plus 10 plus 52. And yeah, those percentage was almost 40%. Now we move to other distribution of our. So those are basically the classes of passwords according to the alphabet they are originating from. The other classification we have, I mean, the passwords according to their lengths, which is very crucial thing. So you, as you noticed, most of them, or yeah, like 131 password have a length of 131, but almost half of them into those 3 categories, 8, 9, and 10. So and this is in the absence of any password policy enforcement on students on how to pick their passwords. So the students were picking their passwords without any enforcement on any rules, but they were kind of having at least 8 up to 10. This is the most of the students. And oh yeah, students picking only passwords from small letters. Those were, I mean, 200 students didn't do that, but the rest, like 460 or 57 for accuracy, we're doing that, which is, yeah, telling us that they were not very, maybe they are picking lengthy password, but not very strongest password. Those are the students who were picking password with capital letters. So almost more than half of the students were having no capital letters in their passwords, but the other half used it. Digits, only 19 students never used a digit in his password, but the rest were. And this says how many like digits are using. So like third of the students were having 4 digits in their passwords. Symbols or special characters, how many students were using those? more than 60% of the students were not using any symbols in their passwords, which is not very good thing to strengthen the password. As you know, I mean, the more complicated or the more, say, alphabet size, the bigger the alphabet size of your password, the stronger your password will be. So more than 60% were not using any special characters or symbols. Now we have 2 extra classifications for our passwords. So we call the first one alpha distribution. And what is an alpha? So we have alpha weak password and alpha strong password. An alpha weak password is a password that is generated from at most 2 sets of characters. So if we get back to this different sets, so if any password is, for instance, digits and symbols, 1 case letters and digits, 2 case letters, those are alpha. We consider them alpha strong. So any password generated from at least 3 sets, at least, this is called alpha strong, while 2 sets and below is called alpha weak. So again, going back to this table, so this is alpha weak. The case class 2 is also alpha weak. The third class is also alpha weak. The alpha strong is starting from 7. So 1 case letter, 2 case letters. So you have uppercase, lowercase, and we have digits. 8 is also alpha strong. 9 is alpha strong, and finally 10 is alpha strong. So 7, 8, 9, 10 class numbers are alpha strong because they belong to, they have the alphabet, the password is generated from at least 3 sets out of the 4 sets we have. And then we have another classification, categorization for passwords, which is based on entropy. So according to NIST cut point, the American National Institute of Standards and Technology, they have this cut point of 80 bits of entropy. So if any password has at least 80 bits of entropy, we consider that eta strong, while eta weak for passwords with less than 80 bits of entropy. And here we have this, of course, we missed this distribution of alpha distribution. So we have almost 50 is alpha weak, while above 50 is alpha strong passwords. But I mean, the percentage is not very satisfying. I mean, should be most of the students here in this alpha strong category, but this is what we had. While the eta distribution, the other distribution that is based on the entropy, we have the results were more disappointing than the previous one. I mean, almost 90% of the students, more than 90% of the students were having alpha eta weak passwords, and only 9% of them were eta strong according to this cut point of NIST. And this is again the distribution. So this is specifying how these 9% are distributed. Yeah, so 80 and above. So those are the 9% only, and the others are just in this You see, I mean, this is very telling also. I mean, like this very huge percentage, or maybe above 20%, 30%, because this is 10, okay? This is like 10, the people here, while those here are like maybe 30, are less than almost 25 bits of entropy, which is not very good. Yeah. Findings, majority of our students don't tend to create strong passwords on both of the definitions we have, the alpha distribution and the eta distribution. All Cherka or approximately 50% pick an alpha weak passwords, and more than 90% pick an eta weak passwords. Due to the lack of strong password policy, so as I said before, we haven't enforced any password policy on students or requirements on passwords. And maybe our students were were not considering this programming platform as serious as it should be, or in picking the password. But anyway, this is not had. So in conclusion, we have this deficit of about 650 passwords. We assume that they were realistic, but not that maybe serious. The students didn't take that very seriously. That's why their passwords were not that strong. We analyze them by their length, by their frequencies, and the existence of different sets of symbols like lowercase letters, uppercase letters, digits, special characters, and so on and so forth. We've also coined out those two definitions for weak and strong passwords. One relied on the alphabet called alpha distribution. The other one is relying on the entropy we call eta distribution. And we use this stressed cut point of 80 bits per password to classify eta strong from eta weak, while in alpha we say that if a password belongs to 3 sets, it will be considered alpha strong. Yeah, and so what is the main recommendation is to enforce, don't rely on people education to pick their passwords. People tend to pick easy passwords for their memory purposes mainly, to remember it, to recall it. And more than religiously, they tend to reuse passwords. So whenever they will use a password from different system, and then if that system is weak or your system is weak, one will lead to the break of the other in the first password breach or leak. We need to, of course, following a secure method to store passwords, because the main motivation behind that, I mean, finding passwords in plain text is very dangerous. So maybe sorting or preparing after sorting, even hashing before all of that. Of course, endorsing secure design approach in system development life cycle. So what is said to be a security by design, and conduct a more rigorous investigation maybe about password quality using a bit of different metrics and tools. Okay, that's all I wanted to say. Maybe relatively shorty talk, but if anyone has any question or recommendation or comment, please.
Okay, I have a question for
Yes,
you,
please.
Omar. You said that it is important to not reuse the password several times. How can you find a metric on this kind of reuse? Because you just see the password for instance, for 1 year. Is it possible to extend um, this metric to several years? That is, you have certain student, for instance, that are 1 year, and you can have the same student another year. So it's perhaps possible to sometime have a metric on this this problem? Have you something about that?
Well, it's a nice idea. Thank you for that. I mean, but let me first make sure that I got what you are. You, I mean, like kind of the age of the password as a matrix.
But I
Like
mean, perhaps,
attaching an age to the password as an additional metric. That
perhaps
would
you
be,
just compare the password of 1 year with another year and see if they are equivalent or they are close, in fact. So
yeah,
you can
yeah,
use a metric for that. Is
yeah. I
just
got that.
one letter which are different or something like that.
Yeah, that would be very nice. I mean, like saying aging passwords or reusing password or reusing parts of the password, maybe that will be something to think about, and maybe see if yeah, we could maybe someone has some, yeah, that would be very nice. This comparative relative password, like from time to time or from yeah, of course, part of the password policy is changing password periodically, but you still can have this like repository of all passwords, and then start like comparing. Are they like developing in entropy, or are they developing in this alpha distribution? They are still the same. This could be a very nice way of looking at it. Thank you for that. Yeah. So, any other questions, please?
I have a question.
Yeah.
Do you hear me?
Maybe one of us must mute.
Yeah.
Maybe me.
Yeah. Okay. Thank you. Thank you for the good presentation. My question is, how do you think in such studies, sometimes when user is going to provide a password, but the web browser, like a Chrome, allows you to generate instead of you, like how this may influence on the study, and how to work with that effects? Thank you.
Yeah.
Yeah, because I noticed in your data some of the password with the high quality, like with the high entropy.
Yeah, thank you for the question, and sorry for this audio issues we're having here when we connect the monitor. So yeah, I mean, this is now been a thing since several years. This password managing tools, which are brilliant to have, but and people are using it and relying on it, and of course they are relying on this master password, let us call it, that is you use to encrypt the others, all of the others in your Chrome or browser, whatever. But for our students, I mean, we don't assume that they used any password manager to suggest passwords for them, because they were using university devices that they are not looked into using their. So that's why this browser thing is not suggesting anything, because they are not personally looking into the browser. Yeah, they are using computers, general computers. Thank you for this.